Okay, so in vertex form is not new. You saw it in Algebra 1, but you actually saw it this year as well. So even though it was very brief, we were not focused on parabolas at the time. Vertex form we did talk about in Chapter 2 with transformations. And then if you were here the day before Thanksgiving, I talked about it when we did that Desmos activity as well. So the first part today, ultimately you want to be able to write quadratic functions in vertex form and then also graph them if they're given to you in vertex form. So vertex form of a quadratic function is this formula here, y equals a times the quantity x minus h squared plus k. In vertex form, the ordered pair hk is the vertex of the parabola. So normally when we had parabolas given to us in the form ax squared plus bx plus c, we had to use a formula to find the vertex. Here you do not. When you have the equation in vertex form, you just have to know what is h, what is k. That is your vertex. And then because the axis of symmetry goes through the vertex, the equation x equals h is the axis of symmetry. So the h, notice, is the x value of your vertex. And then a determines the shape of the parabola and the direction in which it opens. So a, in the formula ax squared plus bx plus c, this a and the a in vertex form are the same. So if we had an equation in standard form, this would be the standard form. So if we had an equation in standard form and then we wrote it into vertex form, the a in both forms would be the same value. So the a still functions the same way, meaning if you want to determine if a parabola is going to open up or down, we said in standard form, if a was positive, it opens up. If a was negative, it opens down. That is the same thing here. If the a value is positive, this is going to open up. Negative, it's going to open down. So the a value is the same. But then notice this equation then has a b and a c. This equation has an h and a k because those represent different values. So kind of where this is leading, why we even have vertex form. Vertex form is helpful if you're graphing using transformations, which I don't expect that to be the way that you graph. I don't expect you to graph purely by looking at an equation and saying, okay, it's going to be shifted right 3 units and up 1 unit, and then it's reflected, and then you draw a graph. I would rather you graph by finding the vertex, finding the axis of symmetry, plotting points. This, though, not only will come up in this chapter, but I know Chapter 9 means nothing to you right now. When we get to Chapter 9 with conic section second semester, we revisit parabolas because they are a conic section. We'll talk about what that is when we get there. But you will see this formula again in Chapter 9. So vertex form, why it's really helpful to us is you can easily see what your vertex is. So in example 1, I know there's 3 problems. We are going to go from a standard form equation into a vertex form equation. So any equation that starts out in the form ax squared plus bx plus c can be written into this form by completing the square. So we're going to review completing the square. And hopefully you can see where completing the square would come in to play. You have a quantity that is being squared in vertex form. So if you were able to complete the square and factor it to be a quantity squared, that's where completing the square is going to be helpful to us. So we're going to look at example 1. It is a process to get here, so just make sure you understand the steps. There is going to be one for you to practice without me. But given your equation, what you want to do first is you want to isolate, or rather kind of group together your x terms. So in this case, we have x squared minus 2x. I'm going to group those together. The plus 4 is still there. I'm not moving it anywhere. It's going to stay where it is. But I'm just going to kind of ignore it for now. It's not part of my completing the square process. And what you want to do with your x squared minus 2x is you want to, again, ignoring the 4, you want to turn this into a perfect square trinomial. So you want to find a value of c to add on to the end that would make it a perfect square trinomial, complete the square. So I'm going to rewrite this as, still in parentheses, x squared minus 2x, but then I'm going to put a plus blank because I want to find that value that will complete the square. Close the parentheses. I still have the plus 4 on the outside. And then I'm going to add another blank, and I'll talk about what to do there. If you remember when we solved equations by completing the square, I had you write a plus blank on either side because what you add to one side, you have to add to the other. Here, both of these blanks are on the same side of the equal sign. So this one's going to work a little differently, but you still need to have two of them because you need to balance it out. So I'll talk about that. But before we get to that point, we need to find this value. So this is reviewing completing the square. How do we find the value that makes it a perfect square trinomial? B over 2 squared. And again, I'm giving that to you. You just have to know that that is what it's used for. So we have negative 2 over 2 squared, and negative 2 divided by 2 is negative 1. Negative 1 squared is positive 1. Now, again, because these two blanks are on the same side of the equal sign, I don't want to add anything to the y because I'm going to want the y to be by itself. But because they're on the same side, here, in order to keep it balanced, if I'm putting a positive 1 on this side, to balance it out, I also need a negative 1 on that same side. If they were on opposite sides, I would be adding 1 to both sides. But because they're on the same side, they need to be opposites to keep it balanced. We are not re-adding them together to make a 0. We're doing this for a reason. We're going to factor this. But this is purely to balance it out. I can't just add 1 without having a balance to it. So this one will have the opposite sign. And then from here, you now have a perfect square trinomial that you want to factor. And again, it's going to factor to be one quantity squared. So I have y equals, what quantity squared will it be? How will it factor? Ellie? X minus 1 squared. So the shortcut again, it's minus 1 because your b over 2 was negative 1. That's one shortcut. Another shortcut is the 1 is the square root of 1. The minus is because your middle term is minus. If you don't remember either of the shortcuts, if the shortcuts don't make sense to you, recognize that this is still a trinomial. You can still set up a diamond. And I say that because I don't want you to try to be remembering a shortcut and that's why you get it wrong. So the diamond still works. In this one, you're multiplying to positive 1 and adding to negative 2. That's negative 1 and negative 1. And that's why it's x minus 1 quantity squared. So the diamond will still work. And then after your quantity here, you can combine the 4 minus 1. So that would be plus 3. And now if you look at the formula for vertex form, it is in vertex form. That is the same equation, but in vertex form versus standard form. Okay, so why we would use this, like I said, it's an easy way to find your vertex. So I realize the directions just say to write it in vertex form, we did that, but I want you to understand how this would be used. So from this formula, what would the, so look at your formula here, what would the a value of this equation be? What's the a? I heard somebody say 1. There's a 1 in front of that x minus 1 squared, so a is 1. Notice in your standard form, a was also 1, so the a value doesn't change. What is the h value? Not negative 1, you're in the right spot. Not negative 2. Positive 1, yes. So the reason it's positive, notice in the formula it's x minus h. So if you have x minus 1, h is really positive 1. So h will always be the opposite of the sign that is there. So if it's x minus 1, h is positive 1. If it was x plus 1, h would be negative. And then what is k? K is 3. And k is always the sign that you see. So if you see plus 3, k is positive 3. So why you'd identify these, hk, that is your vertex. So the vertex for this parabola is 1, 3, your h and k. So thinking ahead graphing-wise, if you had an equation in this form, you can find your vertex immediately, plot your vertex, and then you just need to find other points to graph. But your vertex you have right away. Okay, so we're also going to look at B together. So one more example together. This does have one difference to it, and that's the fact that it has an a value that isn't 1. So there is an a value of negative 3. So we are still going to start out by grouping the x terms together. So the plus 10 is off to the side. But if you remember with completing the square, we talked about this in 4.5. To complete the square, your a value must be 1 in order to complete the square. So we can't have that negative 3 in front of the x squared when we complete the square. So when we solved equations, we divided everything by it. Here we don't want to do that. We don't want to divide each side because, again, we want y to stay y. We're just working with one side of an equation. But what we can do is we can factor it out. So I'm going to have y equals, I'm going to take the negative 3 out. So you're not taking out a GCF. You're not taking out an x. You're just taking out negative 3. And you're only taking it out of these two terms. The plus 10 is totally separate. So if I factor out a negative 3, I'm now going to have a positive x squared. When I divide minus 18x by negative 3, I now have plus 6x. I'm going to put a plus blank right away. And then the plus 10 is still plus 10. It's outside of the parentheses, so I don't have to divide it by negative 3. And then I'm also going to add another blank after the 10. And then from here, so now make a note, your b value is now 6. It was negative 18, it's now 6. So to complete the square, I take 6 divided by 2 and square it. So that's 3 squared, which is 9. And another difference, again, it still ties into your a value being negative 3, is that to balance this out, I'm not putting 9 here, or negative 9. Even though I'm not going to redistribute the negative 3, this 9 is still in parentheses that's being multiplied by negative 3. So this value, if I did redistribute the negative 3, is really negative 27. So to balance this, I need to balance negative 27 with a positive 27. So the 27 is coming from 3 times 9, and it's 3 times 9 because of that a value of negative 3, except it was negative, and we need to balance it with a positive. So you could say we did that same thing in number 1, but when your a value is 1 times anything is just going to be that number. So if there's a value other than 1 in front, it has to get multiplied to the value you're adding on. And from here, we now again factor this trinomial. So I have y equals, I still have the negative 3, and then I know factored, it's going to be a quantity squared. What quantity will it be? The factored form. X plus 3. And then I have, at the end, I'm now adding 10 and 27, so I have plus 37. And that is the vertex form. Grace? Why isn't it negative? Because when I multiply these, it's negative, so to balance it, I need a positive. And it's because they're on the same side of the equal sign. Okay, so I would like you to do part C. So I want you to write that equation that's in standard form, write it into vertex form, following the examples we did. Oh, you used the wrong p-value. Your p-value is now -6, not -12. When you take the 2 out, you have to use this one. So that this value is correct. All right, I know some of you might be finishing up or just changing something, but double check. Again, when I walked around, I kind of looked at one person's in each group. Hopefully you're comparing with each other. If the one I saw or glanced at was okay, I moved on. But check with each other as well. Make sure if you are taking out the A value, that you are using your new B value. You're not using the original, you're using the new one to complete your square. Okay, any questions on C before we move ahead? Okay, now with the remainder, we are going through example 2. Examples 2 and 3 are the same type of example. So we're going to go through example 2. I'm going to get you started on 4, but I want to make sure you have more than enough time you need for the homework quiz so you're not rushed through that. So for example 2, this is still writing an equation in Vertex form, but you are not given an equation. Instead, you are given, in example 2, you're given a graph, but you can write an equation in Vertex form as long as you know the vertex, or at least can find it from a graph, and you know one other point the parabola goes through. So example 2 says to write the equation in Vertex form for this parabola shown in the graph. I'm just going to write down the formula for Vertex form. So y equals a times the quantity x minus h squared plus k. And in order to write an equation in Vertex form, you need to find three values. You need to know A, you need to know H, and you need to know K. If you know those three values, you can plug them in. That's your vertex form. So the two easiest ones to find are the H and the K because that's your vertex. So based on this graph, what are the coordinates of the vertex of the parabola? Yep, 2, -3. That's where our vertex is. So that gives us that our H value is 2 and our K value is -3. So I'm going to plug those in. So I have y equals A times the quantity x minus H is 2 squared. And then since K is -3, I can either write plus -3 or just -3. And then I still need to find A. It's not the value where it crosses, but you can use that point. So to find A, you need one other point on your graph. So either if you're given a graph, you just find another point, or you might be given the coordinates of another point. And Allie pointed out we can see where the graph crosses the y-axis. You don't have to use the y-intercept, but we can see where it crosses on this graph. So we can use that point. That would be the ordered pair. X-coordinate is 0, y-coordinate is -1. And that gives you an x value and a y value that you can then plug into your equation for x and y to then solve for A. So I can replace the y with -1. I'm going to keep A as A. Replace the x with 0. And then I have -2, quantity squared, -3 from my H and my K. But now notice A is the only variable, and you can then solve this for A. So to solve for A, you're going to need to simplify the quantity 0 minus 2 squared first. So I have -1 equals A times 0 minus 2 is -2. -2 squared is 4. And then I still have -3. And now, if it helps, I would rewrite this, because what students want to do when looking at this is they want to subtract 4 minus 3. And you don't do that because 4 is being multiplied by A. So I can rewrite this. Instead of A times 4, that means it's 4A. So this is -1 equals 4A minus 3. So if it helps, rewrite it so that that number is in front of A and you don't end up subtracting, in this case, the 4 and the 3. So to solve for A, I would have to add 3 to each side. So -1 plus 3 is 2 equals 4A. And then when I divide by 4, A is equal to 2/4, which is 1/2, or 0.5. If you had 0.5, that's fine. And once you have your A, you then just go back to your formula where you plugged in H and K and then replace the A with 1/2. So the equation is y equals 1/2 times the quantity x minus 2 squared minus 3. Okay, so again, you need the vertex and you need one other point. So example 3 is the same process. It just doesn't give you the graph, but it tells you what the vertex is and it tells you what other point it goes through. So you still have that same information to do what we did in example 2. Questions, though, on how we did that? Okay, so while you are going to have practice, I have a worksheet for you. I'm still going to talk about 4. You could also look at this problem if you wanted to do it. I can always check. Lisa? How do you know that it's exactly 1/2 just by looking? if you can do that, if you can see exactly what it is, I'm checking to see do you have the right answer when you're writing it. So this would be the way to find A exactly, because say if A is, for example, 3/16, that might be hard to see from a graph. So, but if you can see it, that's fine. Yeah. Okay, and then quickly, I'm not going to do all of example 4. I know I briefly talked about this with graphing. Graphing, think of how you've already graphed parabolas. When I gave you parabolas in this form, you found the axis of symmetry and the vertex first. You still do that if your equation is in vertex form, but you do the reverse order. You find the vertex to then find your axis of symmetry. So what I mean by that is if you look at this equation, to find your vertex, you need to know h and you need to know k. So what is h in this equation? For example 4, what is h? H is -1. What is k? 0. Yep, there's like a +0 at the end here. So your vertex is -1, 0. So you could plot that first. And then because you know your axis of symmetry goes through it, you can then draw that in, and you know your axis of symmetry is the equation x equals -1, because it's the x value from your vertex. So you're just finding them in the reverse order. And then from there, you would just need to plug in other values of x to your equation to find other points. Okay, so I want to get you to the homework quiz, but that's how you would work through an example like 4. If the equation is already given in vertex form, you don't need a formula to find the vertex. You just find it, plot it, and then find other points like we did before.